The first price auction is not the only kind of auction, and we'll talk about several others. We will divide the discussion into other types of sealed bid auctions, the first price auction being one, and what we'll call open outcry auctions. And what I want to caution you is that these are just drops in the ocean of auction types. They're the most basic and most researched ones, and they will give you a sense for the space, but by no means exhaust it. All of these auctions initially will be for a single good, imagining wanting to bid for a Van Gogh or a house or something like that. But towards the end, we'll also mention auctions that where more than one item is involved. We'll start with the second price auction, and as the name suggests, it's very similar to the first price, in which we have some number of bidders. There's a single good. All the bidders submit a bid in the form of a sealed bid, a number written down in sealed envelopes. The envelopes are all opened at the same time. The highest guy wins, and so far it's exactly as is the case in the first price auction. But the difference is that that the winner does not pay the number he wrote down, but rather the number of the highest rejected bid, or the second highest bid. This may seem a little surprising at first. Why on earth would you want to do this? It seems maybe a little unnatural. If you want to maximize your revenue, you might naively say, I'm going to get less money because I'm going to get the second highest bid. But of course, when we change the rules of the game, the rules of the auction, then people bid differently. And so let's analyze what happens in the sealed bid auction. To set it up formally, we have agents. Each agent have a type. Think of it as their value for the good. It's drawn from some domain, and for simplicity, let's imagine the real numbers between 0 and 100. And we will not really care in the context of this auction about the distribution governing these types. What we will care about is, in this analysis, will be that the values the agents have are private, individual private values. We sometimes call it the IPV model, independent private value. And what we mean by that is what's written there, that the payoff to the agent depends on the outcome of the auction, who won and who paid what, but and on the type of the agent, his really value for the good, but not on the types of the other agents. So when everybody bids for the Van Gogh and somebody won and it's worth $1 million to me, that's all I need to know how happy I am. I don't care about the values other people have for the good. So with that, the mechanism looks as follows. We need to specify the actions, the possible bids of the agents, and the payoffs as a result of these bids. So as we said, the bid is simply a number, call it A sub I, in the region here. So these are the bids, and to define the payoff, let's just have a notation A2 to denote the second highest bid among all the bids. And the payoff is simply as follows. If the agent won, if agent I won, and that would happen if his bid was highest than the second highest bid, then his payoff is his value for the good, namely his type, theta sub I, minus his bid. If he did not win, then he got nothing, he paid nothing, his payoff is 0. We need to worry about the case where there are multiple winners, and in that case we simply assume that the payoff is, one way to think about it is that the winner is selected at random among the highest bidders, in which case your expected payoff is simply the your payoff, if you win, divided by your chances of winning, namely the number of bidders, y over here. So this is the auction, and let's analyze it. What we will see is the following, and it's a little counterintuitive, but we'll see first of all that all agents have a dominant strategy. By that I mean all agents will have some strategy. Agent I will have a strategy, A sub I, that's better for it no matter what all the other agents bid and what its type is. So given any of its types and anything the other agents bid, he's better off bidding A sub I than anything else. That's a dominant strategy. That's a very striking property of a mechanism of the auction here. And so since all agents have a dominant strategy, we'll have an equilibrium in dominant strategies. Furthermore, we'll see that the dominant strategy is to simply bid your true value. If this is worth $1 million to you, you'd better bid $1 million, not a penny more, not a penny less. And such mechanisms are called truthful. There aren't many of them. In some sense, the second price auction is the only such mechanism, and let's see why this is the case. So let's write down again the payoff. We've already seen this before. These are the payoff to the agent depending on all the bids and the agent's type. When is the payoff positive? Well, the payoff positive just in case this quantity, and obviously that quantity is positive just in case your type is greater than the second highest bid. This means you want to win, and when would you win? Just in case your bid is greater than the second highest bid, just in those cases in which your payoff is positive. Well, how do you achieve that? Just in case you bid exactly your type. So this condition will coincide with this condition when you bid your type. So that is proof that this mechanism is truthful. It may also still not remove the mystery. You could follow the mathematical argument and nod and still don't really have a good sense for what's going on. So let's look at an alternative kind of way of proving it simply by case analysis. Let's say your value is what it is, plotted there on the line, some real number. Let's look at case number one. Suppose you overbid by some amount. Now let's look at the subcases of that. Suppose you overbid and you lost. The person who won bid above you. Well, had you bid your true value, you still would have lost, still would have paid nothing, and so might as well have bid your true value. Subcase number two, suppose you overbid, and now the second highest bid was below your true value. Well, in that case, had you bid your true value, you still would have won and still would have paid that second highest bid. So here too, it really doesn't matter. You could have bid your true value and your payoff would have been just the same. So far we've seen the subcases where you're indifferent between bidding your true value and overbidding. But now consider the final subcase in which the second highest bid, you've won, but the second highest bid is above your true value. What's going to happen now? Well, now you're in trouble because you're going to have to pay the second highest bid, which is more than the item is worth for you, and your payoff is going to be negative. So now you really wish you had bid your true value. So we've just finished proving that in no case do you want to overbid. We can now do the same and look at the other case where you might consider underbidding. And here I invite you to go through the same sort of analysis and persuade yourself that in all cases you're better off just bidding your true value. That's the second price auction, a very interesting auction with a very strong property. The space of sealed bid auctions is much broader than that. We can imagine something called a kth price auction, where, as you can imagine, k now is something greater than 2, where if the highest bidder wins and pays the kth highest bid. And that is something of a curiosity, although it also has some interesting properties for k3 and larger. Another sort of auction, which is encountered really only in charities or in con games, where everybody puts in a sealed bid and the highest guy wins, but everybody pays their bid whether they won or lost. And you can imagine that you'd end up with a lot of unhappy people if you do that. So these are some of the sealed bid auctions. Moving on to other types of single good auctions, we'll look at open or open outcry auctions. These are auctions where there's some auctioneer, and these are very familiar from the folklore. You have some big auction house that displays a painting, and a auctioneer calls out prices and calls on bidders and so on. To be precise, in order to study it, we look at specific mechanisms that are modeled precisely mathematically. Here are two of them, the English auction and the Dutch auction. The English auction, very familiar. This is the ascending price auction. Unlike the familiar folklore in which the auctioneer invites bidders from the audience to shout out prices, which in fact is another kind of auction that is modeled, sometimes called the Japanese auction. The most studied English auction is one in which the auctioneer calls out prices. Imagine the price starts very low and everybody is in, and then the price increases gradually. And in order to study it precisely, let's assume that in fact it increases continuously with time. And over time, bidders withdraw. Imagine all the hands are up, yep, I'm in. And slowly, as the price increases, bidders start to drop out. And when only one hand is left up in the air, that is the winner. And at that point, at that precise point where the next to last person dropped out, the winner is determined, namely that person whose hand is still standing, and the price they pay is the price at which the next to last person just dropped out. So when you think about it, this is obviously not an unfamiliar scenario, but when you think about it, it really is equivalent in a very particular way to the second price auction. And why is that? Well, first of all, it too has a dominant strategy. If you're a bidder and this painting is worth $1 million to you, well, we start from zero and you'll put your hand up in the air, and so long as the price has not reached $1 million, you'll keep your hand up, because if you're lucky enough to be the winner for anything below $1 million, you're happy. Of course, as soon as it reaches $1 million, you'll put your hand down. And this is independent of what anybody else does. So this is your dominant strategy. And what will you pay if you're a winner? Well, lo and behold, you'll pay the price at which the second guy dropped out, and since their dominant strategy is to drop out exactly at their value, you'll pay exactly the second highest value. And so we see a very strong connection between two auction types that on the face of it are superficially very different. The English auction and the second price auction. And here is another sort of open outcry auction. This is a descending auction, also called the Dutch auction. It's called the Dutch auction because that's how, to this day, Dutch flowers are sold in the famous Dutch flower market, where prices start high. So unlike the English auction where prices start low and bidders are by default in until they opt out, here prices start very high, gradually come down, and when the first person jumps in and offers to buy it, they buy it at that price. It's sort of a game of chicken, if you will. And here again we see a surprising connection. A connection in this case to the first price auction. And the connection here is very strong, even stronger than the connection between the English auction and the second price auction. These two auctions, the Dutch auction and the first price auction, are strategically equivalent. What I mean by that is that what is the strategy space in both of those? Well, it is to choose a number. In the case of sealed bid auction, it's a number to write down on the sealed envelope. And in the case of the Dutch auction, it's the price at which, if the price drops to that number, you will jump in and take the good. In both cases, there is no more information revealed to you before you act on this number that you chose. And what will you pay? Well, if you win, you'll pay exactly that number which you chose. And so this is a very strong property of strategic equivalence. And in this case, we don't need to make any assumptions about the distribution from which the values are coming, and not even make the independent private value assumption. In any setting you choose, these two auctions are really strategically equivalent.